Welcome to Pomodoro Joe for Monday, August 14th, 2023. Today we're doing LeetCode problem 215, kth largest element in an array. This is a medium problem. Given an integer array nums and an integer k, return the kth largest element in the array. Note that it is the kth largest element in the sorted order, not the kth distinct element. Can you solve it without sorting? All right, let's see what we can do. So what they mean by this kth largest element in the sorted order, not the kth distinct element, that means that duplicate values are counted in this k. So if we had 1, 2, 2, 3, 4, both those 2's would count as we're counting our k. So if we went for the third value, it would be 2 because we had 1, 2, 2. That's 3 values. I guess that's the third smallest. I got that flipped around. It should have been largest, but you know what I mean. All right, and it looks like we have a wide range of numbers and they can be negative. So, all right, so let's put 25 minutes on the Pomodoro timer and we will get started. So, the simplest solution would be to use sorting. We'd sort it and then just return our value at the negative kth index. Okay, so that would be the way to do it with sorting. But it does ask us if we can do it without sorting, so let's see what we can do. Now, my immediate thought, since we're looking for the kth largest element, that might work really well with a heap. Now, if we had a max heap, then we pop k elements off the top of the max heap. That should give us the kth largest element. So let's do that. So it's kind of sorting because we're using a heap, but it's not really sorting because we're not directly calling sort, so it's nebulous. All right, let's use a heap. So the first thing I need to do, in Python, they give you a min heap by default. They don't give you the max heap. So the trick to using Python's default min heap as a max heap is to basically just flip all your values around. So anything that's positive becomes negative, and anything that's negative becomes positive. That way, when you pop things off the stack, they are the smallest values. Then you have to invert it again to get the real value back out. So let's do that first. Let's have like reverse nums, or I don't know what I'll call this. Yeah, reverse nums. It's not really reverse. What do I want to call this? Flipped nums. There we go. Flipped nums. That's going to be, let's see, for every number in our nums, we want to flip it negative n for n in nums. There we go. So that should give us all the negative values of our nums, or basically the negative version of the value in nums. Next, we need to heapify this. So heap q, heapify. And we'll heapify our flipped nums. Let me fix this typo. There we go. All right, and now we just need to pop off k nums from the top of our heap. So our result will just equal, we'll start at not 0, we'll start at none. All right, and then for, what do we call this? I in range k. Our result will just equal heap q heap pop, and we'll pass in our heap, which is this flipped nums. All right. Maybe I should just call this heap. That would probably be better. I'll call this heap. All right, so our heap will just start out with all the negative values of our nums, then we'll heapify it, and then we'll pop k elements out of our heap, and then we return the negative result. Remember, we have to flip all this back. All right, let's try that. Seems to work. Let's submit this and see how we do. And we pass, and we actually do quite well. So we beat 91% for runtime and 32% for memory. So yeah, that's a valid solution. It doesn't specifically sort. It does kind of sort because the heap is sort of sorting as we push things into the heap, or when we call this heapify. So it's questionable whether or not this counts as sorting. I would say it counts as not sorting. All right, let's go back and do this another way that does not sort at all. All right, so if we don't want to do any sorting at all, what's another way we could do this? So we could go through, find the minimum value of our nums and the maximum value of our nums, and then count how many of each number in between we have. And we can either store that in a dictionary or we can store that in an array. Then we have this sort of count of all the numbers from the min value to the max value. Then we'll just go through starting at the max value. We can count backwards until we've found k values below the max value, and we return that. I'm not making any sense because I'm tired, but we'll just go through this and see how it goes. All right, so our min value, that's just going to be the minimum number. And the max value, that's just going to be the max number. Okay, for this, I think I'll use an array because it's easier to go through, but we could use a dictionary if we really wanted to. But let's go through our array here. So we'll have counts. So how many of each of these numbers do we have? Well, we'll start out with 0. And how many of these values do we have to hold on to? Well, let's see. We'll have our max val minus our min val. Now, if they're the same, let's say our max value is 4 and our min value is 4, well, this will return 0. And we need at least one element, so we'll have +1. All right, so that will give us our initial counts. Now we actually have to go through and fill out these counts. So for our number in nums, now that number is actually represented by the index into this array, but we've shifted everything down by this min value. So we're not actually going to pad our array with 0 up to this min value. So the index into our counts array actually has to be adjusted for this number. So I'll call this index. And that's going to be, let's see, our current number minus our min val. So if n is the min val and we subtract the min val, that's going to give us index 0. That sounds pretty good. All right, so our counts at this index plus equals 1. We have one more of those numbers. Okay. Next. Now we have to start counting backwards from the highest index to the lowest index, basically subtracting however many of that number we have from our k. So I'll have, what do I want? I'll have an index. We'll start it at the max index, which is just the length of our counts, minus 1. That's the max index. And we need to keep track of our remaining k. So I'll have remaining k. That's going to be k. All right, so while our index is greater than or equal to 0, and remaining k is greater than 0, so we're going to be counting down. So as long as these conditions hold, then we'll take the count at this index, so that's the maximum value so far. So let's see, count at this index. So I'll call this count. So the count of this number will be stored in counts at this index, and we can reduce our k, so our remaining k is reduced by that count. All right, so if we have 100 5s, we can reduce k by 100 when we're at index 5, or the index adjusted 5. All right, and then our index has to be reduced by 1. So this should get us to the place where our index matches the maximum or the kth maximum value. Now we also need to readjust our index to get our number back out by this min value. So for here, we have to return our index plus our min value. And we do have to add this extra +1 because we'll be subtracting 1 from the index after we've already reduced our k. So we do have to have 1 more here. All right, so this should give us our kth maximum value. All right, it works. Let's see if this does any better than our heap. And it does. It does significantly better than our heap. So our heap was pretty awesome at a 91%, but this gives us a 99.53% and an 89% for memory. So this by far is the better solution. However, I will say it's a better solution in terms of runtime and memory. In terms of readability, this, I don't know. You can read it, but it's not nearly as apparent as this. Okay, well, I don't have a lot of time today, so that's it for me. Hope you enjoyed this, hope you had fun, hope you learned something, hope you can go out and write better code.